systems of linear and quadratic equations is going to seem very familiar to you. The how-to for this is just like what we did with systems of linear equations. The difference is you're looking at the intersections of a parabola and a line instead of two lines. So our target is that we can solve a system of equations with a quadratic and a linear function. Just like with linear systems, there's going to be multiple ways to solve these. We're going to look at graphing, which is probably going to be your preferred method, especially when you have a graphing calculator handy, elimination, and then also substitution. Oh, we skipped ahead. Okay, so looking at graphing, as it was with linear equations, the solution is going to be where the graphs cross. So I have a few different lines here for you. So if I added a parabola to this right here, I have two solutions. I have one right here and one right here. And this is going to be the majority of your parabolas, the majority of your systems. When you have one solution, that's going to be where the vertex touches the line. Therefore, there is only one solution, and that's going to be the vertex. And the third type of situation is going to be when there is no solution, where it looks something like this, where they do not cross and they never are going to cross. We'll get a lot more practice of this in the classroom, where you can actually use your graphing calculator. You can use the functions in the second calc function, and that's going to be intersection. You'll need to be able to spot, are there two solutions, are there one, or are there none? Because when you do that calc function, if you have to know there are two solutions to be able to calc this intersection here, and then go through that process again to calc this intersection here. The second method that we're going to look at is elimination, and over here are the steps. So the first step is to eliminate y, because we want it to be 0 equals and then that quadratic, and then we'll solve from there. So in order to do that, line up the equations in standard form. The given ones here are already standard form. You may need to go through and get it in the form of y equals ax squared plus bx plus c, or if it's the linear, y equals mx plus b. You'll need to multiply one of the equations by -1 so that the y's cancel. I'm going to choose to do this top one up here so that that negative x becomes a positive x. So I have negative y equals negative x minus, no, I'm sorry, not negative x, whoopsie daisy, positive x minus 3, because I distributed that -1 to each of those terms. Now, in order to eliminate, I'm going to have to stack these so that they have their like terms with each other. So I'm going to go ahead and take this x minus 3, I'm going to move it over, and I'm going to leave a blank where the 0x squared would have been, because when I move this one down here, that's going to be y equals x squared plus 0, because I don't have an x term there. I could put a 0 here for the upper x term if that makes you feel better, plus 1. And so now that they are stacked up, I can combine the like terms. So -3 and 1 is -2. X and 0 is x, plus 0 and x squared is x squared. And the y's canceled. Negative y and positive y leave me with 0. Now I'm ready for step 2. Step 2 is to factor and solve for x. So I have it down to a quadratic. I'm going to bust that out into my parentheses. Since my x squared term doesn't have a coefficient, I know that my first terms are x. And I'm trying to think, what are some things that can multiply to get -1 but add to get +1? That would be -1 and +2, because that would end up being -x and +2x, which would add to be +1x. Now I'm ready to solve for x. So this first x here, if I bust it up to the baby equation, is going to give me x equals +1, and then I'm going to have x equals -2. Now, since the solutions are actual coordinates, I'm going to have an x and a y. I need to take these x values, this is step 3, and substitute that into one of the equations to solve for y. Let's do this top equation. The top equation, I'll rewrite it down here, was y equals negative x plus 3. So if I substitute that in, if I put a 1 in there, y equals, I'm going to move that over here. Oh, not the whole thing. Okay. Okay, I'm going to substitute this over underneath the 1 so I know what coordinate it's going with. So y would equal negative 1 plus 3. Therefore, y would equal 2. So one of my solutions is 1, 2. The other solution is going to come from substituting negative 2 in for there. Y equals negative 2 plus 3. Negative 2 is the same thing as positive 2, plus 3 would be 5. So y equals 5, giving me the coordinate of negative 2, positive 5. So there are my two solutions to that system, 1, 2, and negative 2, 5. If you were to graph those same equations, that would be their intersections. The third method is substitution, and so for that, your first step is going to isolate one of the variables in one of the equations, and that is already done for us. Then I'm going to write a mega equation by substituting. Since both of these are set equal to y, I can take 4x plus 10 and put that in for y here. So my mega equation will be 4x plus 10 equals x squared minus 2x minus 6. So I've wrote that mega equation. I'm ready for step 3. Step 3, I want to write it in standard form, which means I need to get all of these terms over here moved to the right side. It needs to be set equal to 0. In order to do that, I'm going to move 4x by subtracting 4x on both sides. So that's going to be put underneath negative 2x. And I'm going to subtract 10 from both sides. So that's going to come over here by the negative 6. That cancels. That cancels. Let's choose black here. So I have 0 equals x squared. That becomes negative 6x. And that is negative 16. Ready for step 4? I'm going to factor and solve for the x value. So let's put that into parentheses. So I want to get two numbers that multiply to get negative 16 but add to be negative 6. Since my first term is x squared, I know that in each of my binomials, not x squared, it's going to be x. There we go. They're going to be different signs for it to end up being a negative. And with the different signs, my negative one should be larger so that the negatives win the sign more. That is going to be a negative 8 and a positive 2. That's because when I FOIL that in my head to check it, outside would be 2x, inside would be negative 8x, which would simplify to negative 6x. When I multiply my last terms, negative 8 times positive 2 give me negative 16. So very similar to what we did with elimination, I'm now going to solve these out. I have x equals positive 8 would be one of those solutions, and x equals negative 2. And I will substitute those back into the original equation. Let's use that bottom one, which I'm going to rewrite it down here, 4x plus 10. I'm going to substitute those x values in to that equation to find the corresponding y value. So when x equals 8, y would equal 4 times 8 plus 10, which will be 32 plus 10, which is 42. So one of those coordinates is 8, 42. I'll do the other one in blue. So when x is negative 2, put that back into that equation. Y equals 4 times negative 2 plus 10. 4 times negative 2 is negative 8. Negative 8 plus 10 is positive 2. So that coordinate would be negative 2, positive 2. For all of our examples, our system has had 2 solutions, which, like I said, is going to be most of the time. I personally prefer graphing, and we will get a lot more practice with graphing in class so that we have those graphing calculators to do a lot of the hard work for us.